There it goes. Okay, so what we're going to do today is we're supposed to be able to determine next the net external forces. We're supposed to read chapter 4, section 2, 125 to 129. So I'm going to start with what I have down. So what it's going to be doing from today and tomorrow, and then also Thursday, is going to be talking about Newton's three laws. So when you get here tomorrow, you're going to have a wheel, which you're going to make fill out for Newton's three laws, plus the diagrams that we've been doing. So the first thing that I want to talk about is I want to talk about what the first law of Newton's first law is. And what that is that an object at rest will stay at rest, and an object that moves unless acted on by an outside force. So when we're talking about Newton's first law, we talk about inertia. Okay? Hold on just one second, Jordan. Yes, sir. Yes, sir. It's in my Project Lead the Way room. All right, sir. Thank you very much. I appreciate it. Sorry, Jordan. So, law of inertia, something's at rest unless acted on by an outside force. So you need to make sure that you have written that down. And what it does is it's actually talking about net force. We talked about net force yesterday by doing those motion diagrams that we did yesterday. And then today we're going to talk about it a little bit more. So what I would like you to do is I would like you to open up your textbook to the first sample problem. The first sample problem that we're going to go over is on page 127.
127?
Yes, sir. And on page 127, it says a muscle responsible for closing your mouth is the strongest muscle in the human body. It is able to exert a force great enough to lift a mass of 400 kilograms. The force of binding has recorded at 4.3 times 10 to the third newtons. If each force showed in the diagram below, the magnitude equals the force of a bite, determine the net force. So the first thing that they did is they wrote down what the variables were. So we have our first force, which is a negative 4.33 times 10 to the third newtons. Our force 2 is 4.33 times 10 to the third newtons. And then our force 3 is 4.33 times 10 to the third newtons. So what they're doing is they're actually talking about a mouth, and they're diagramming your upper lip, your middle, and then your lower lip. So it shows you a diagram. Here's my force 2. Here's my force 1. And here's my force 3. Now, they're all 4.33 times 10 to the third power. And remember, when you do these, make sure that you show these vectors that are involved in that. And it's telling us the angle from force 2 to force 3 is 60 degrees. Okay, a negative 60 degrees. Now, that automatically tells us we need to change our calculator into degrees to do this, right? Because we have an angle that's involved in it.
Yes, ma'am. We're
looking for our force net and our angle of our net today. So based on what they did there is they used this funny looking E, Fx, and E, Fy. And what that says is that's all the sum of the forces of X, all the sum of the forces of Y. And it told us what they did is they say they took 4.33 times 10 to the third newtons. They added 2.16 times 10 to the third newtons. And if you put that in your calculator, so remember what we did yesterday, we actually had our calculator on the bottom so you could pull it up. So pull up your calculator. The first thing we know we need to do is we need to change this into degrees, right? So what we're going to do is we're going to try to do this equation. So it's 4.33 times 10 caret to the third power over plus 2.16 times 10 caret 3 over and enter. Now in the book, it tells us that it gets 216 times 10 to the third Newton. Did we get that? No, I'm looking at the wrong thing.
I got 6,490.
I did too, 6,490. So, oh, there it is. I'm looking at the wrong one. And it has 6.4 times 10 to the third. So let's change this. And how would we change it in our calculator to get the scientific notation? We would go to mode. We would move ours over to scientific and hit second, answer, enter. And I got 6.49 times 10 to the 9th power. Is that what you got? Jordan, are we able to do that with your calculator?
Yes, ma'am, I got it.
Okay, cool. I'm sorry. I'm so used to you talking to me now. I was waiting on you. Okay, so
You're good. I was making sure.
So the next thing it's doing is it's looking for the sum of the y forces. So the sum of the y forces, remember, you have your x and your y. We have a negative 4.33 times 10 to the third newtons. And we're going to add that to our negative 3.75 times 10 to the third newtons. So let's see what we get with our calculator for that. So I'm going to take a negative 4.33 times 10, caret to the 3, close my bracket, and I'm going to add, and I'm going to do a negative 3.75 times 10, caret 3, whoops, did do the caret, there we go, 3, over, close my bracket, and I got negative 8.8 times 10 to the third.
I got that as well.
Cool. So what they had to do first, before they had to solve the problem, they wrote down the variables, they do the diagram. We found out it was an angle, so we actually have to change ours to degrees. And then we have to get the sum of our forces of our x and y axis before we can actually do the math problem. Okay? Everybody good so far?
Yes, ma'am.
Done. Then after that, we have to find our force net. So to be able to get our force net, they did the square root of force x net, and they squared that, plus our force over y net, and they squared that. So what we're going to do now is we're going to take the two numbers that we got here, and we're going to plug it into the square root. Okay? So really, is a square root of 6.49 times 10 to the third newtons squared plus a negative 8.08 times 10 to the third newtons squared. So let me take my calculator. I'm going to do my square root first. Open bracket, 6.49 times 10, caret 3, over, close, square. Then I'm going to add, open bracket, negative 8.08 times 10, caret 3, over, close my bracket, and square that. And I got 1.036371073E4. Is that what y'all have?
Yes, ma'am.
Fantastic. So in the book, what they did is they changed it and they looked at this number here to 3, so it kept it there. So what they did is they just took all that out and they did times 10 to the 4th power, and boom, we're done with that to find what our force net is. But we're not done yet. The last thing we have to do is find our angle. So to be able to find our angle, we're going to do tan -1. Why are we doing tan -1?
We have to get the angle.
of where it's at, right? We're looking for this angle. We're looking for which angle? There? What angle are we looking for? We have this angle at 60.
We're looking for the net angle, right?
Exactly, the net, the whole angle. Very good. Thank you, Jordan. So if we're doing our tangent -1, we're going to take our 8.08 and our 6.49, the numbers that we have here. So we're going to do negative 8.08 times 10 to the third Newton over 6.49 times 10 to the third Newton. And that's all we're doing. So in our calculator, what I'm going to do is I'm going to do by tan -1, which is our second tan, right? Now I'm going to do alpha y inner to get my fraction. I'm going to do negative 8.08 times 10 caret 3. I'm going to go down 6.49 times 10 caret 3 over, and close my bracket. And I get negative 5.12279488E1. Is that what you get?
Yes, ma'am.
Fantastic. So what they just did, they just changed it and they made it 51.2. So what they did is they took the E1 off, moved the decimal over 1. You could have put 5.122798 if you wanted to, E1, or you could take the E1 off and then just move that decimal over to 51.2 degrees. Questions about the practice problem?
No, ma'am.
The practice problem was probably harder than any other problems that we had to do today, but they always like to show you how they figured it out. Now, so now you'll know, based on your math, that information. So now what we want to do is we want to go and turn our page. So in your textbook, turn to the next page on page 128, and we're going to do these 3 problems. So let's look and see what it says. It says a man is pulling a dog with a force of 70 newtons directly at an angle of 30 degrees to the horizontal. Find the X and Y components of the force. So 70 newtons is what variable? The force. 70 newtons. It says that he has an angle of 30 plus 30. So my angle is plus 30. And it says here that we're trying to find the X and Y components of that. Now, Bailey, how do you find force X and force Y? What do we have to do for that?
Use the formula?
Use force cosine angle. Very good.
Yes.
Thank you. So that's force, cosine, and then the angle for this one. Okay? So, Abby, well, how do I find the force of Y?
I have no clue.
Okay, so it's sine, right? Force of sine angle. Okay, remember when we first did at the very beginning of the book, we drew our plot and we showed our X and our Y. I'll bring that back up again tomorrow so you can look at it so you can figure that out. But that tells us if we use sine or cosine based on what we're looking for. So Jordan, how do I do force X?
You have to do 70 coasts, and then 30.
30, okay? So first thing we want to do, change our mode back to radian again, right? Or do we need to keep it in degree?
Keep it in degree, but change it
Right,
back to
we're gonna
normal.
keep it in degree. So do it for your calculator on your desktop. Tell me what you got. What'd you get, Jordan?
60.62177.826.
Exactly, 60.6, okay, is my force of X. And that's going to be in newtons, right? Because it's force. All right, Hayden. Do Fy for me, please, sir. That would be 70 sine 30 for me, please, in your calculator on your desktop. Tell me what you get.
I'm so lost right now, but you said put what next?
I said put the number 70 and use your sine button and do your 30 and tell me what you get on your calculator.
70 sine and then put 30 in the little parentheses?
Yes, sir, and make sure that your mode is in degrees first.
35, correct?
35. 35 newtons, right?
Yes, ma'am.
Yes. Well, that's our answer. That's our answer for question number 1. Is there any vectors to draw? Is there any free body diagrams to draw? Could we draw a free body diagram now that we have it?
You could, yes.
Okay, so let's see. All right, so what am I going to do here?
Show of a man pulling on his dog.
Your dot's going to be the dog, isn't it?
What is our system? Does it tell us what the system is? You got a man walking his dog. Where do we want our system to be? Do we want the man or we want the dog?
The dog.
All right, we're going to do the dog. Sounds good. All right, so if it's the dog, here's my dot. I have a force X and a force Y. How am I going to draw my vectors for that? What vector do you have?
You have gravity.
Okay.
You have the road or the grass or whatever the dog's walking on. And then
Okay,
you have the force of the guy pulling the dog. And I'm not sure, but when you pull something, like they kind of lock their feet and stop, so would that be friction?
So do you agree that there's a force tension because it's a rope?
Yes, ma'am.
Yes.
Okay. All right. So we have force normal on the dog by the ground. We have force gravity on the dog by the earth. We have force tension on the dog by the man. What else we got? This cancels and this cancels. We have a force applied, Miss Sloan. Force applied on the dog by his legs, right? Because he is walking.
Yes, ma'am.
Does that look good?
Yes, ma'am.
Does these cancel out?
Yes.
Is he at stop or is he walking?
No, he's walking, so they don't cancel out.
Oh, that's right.
So my net force is going to be in that direction. Do you agree? My vector here should be longer than that vector there. Do you agree? Yes, Miss Sloan. And my force net is going to be in that direction. Do I have to have any numbers? No, I don't have to have any numbers. I did some math because they were giving me the angles and stuff, right? But I don't have to include it in here if I don't want to right now, because right now we're still trying to practice using force diagrams, right? So diagram should be the dog, normal, gravity, equal. Tension, force applied, this should be bigger, net force should be in that direction. Everybody good so far?
Yes, ma'am.
Okay. Let's go ahead and do question number 2. Okay. Question number 2 says, a gust of wind blows at an apple from a tree. The apple falls at the gravity force on the apple is 2.25 newtons downward, and the force of the wind of the apple is 1.5 newtons to the right. Find the magnitude. Okay. So, Abby, we have a tree, and we have an apple. That apple just fell. What is my system, Abby?
I don't know.
Yeah, you do. My system, Miss Sloan, is the apple, because what we're doing is we're trying to find the apple as it falls, correct? Yes, ma'am. So, Bailey, if my apple's my system, what do I need to have here?
You need to have gravity, and then you
Okay.
need to have, are we taking air resistance into account?
Well, it kind of tells us that there's a wind, so yes, I'm going to say there's an air resistance.
There's an air resistance going up, but the gravity is stronger, and then there's one going out because of the wind.
Okay. So can we say force normal?
Yes, ma'am.
But the force normal is going to be off a little, isn't it?
Yes, because of the wind.
Gravity's more, isn't it?
Yes, ma'am.
Uh-huh. And then we have force applied on the apple by the wind,
Wind.
right? Force gravity on the apple by the earth.
Yes, ma'am.
Normal on the apple by the what?
The
Air
tree.
resistance.
Oh, I like the tree. What do you think right now? This sounds pretty good, Jordan. Because this is the
Tree
thing
do.
that you got to think of. And this is the moment that it falls, Bailey, is it has a force normal already here because it's hanging on the tree, right? The tree's attached to it. And so what happens is when that apple falls and breaks off, there's still a little bit of force normal on here, but not a lot because gravity's taking it over. Gotcha?
Yes, ma'am.
Cool. All right, Hayden, give me some numbers. What does it tell me the force gravity is in newtons?
The force, gravity, and newtons.
Yep. So it says, as an apple falls, the gravitational force on that apple is 2.5 newtons downward. What is my newtons? Hayden?
On Newton on what? On the downward?
Yes, sir. Gravity?
So it would be 2.25 newtons down.
Yes, sir. Yes, sir, it would. Thank you very much. And
Yes,
George,
ma'am.
wind is how many newtons?
Be 1.05 newtons to the right.
Fantastic. So I'm going to go ahead and plug these in already because I just want to put it on this one just to make sure you understand you could. So what am I looking for? It says that I'm looking for the magnitude and direction of the net force of the apple. So Fy equals negative 2.25 because it's falling down. Fx equals 1.05 newtons because the wind's traveling in that direction. And I'm trying to find the force net equals the force of x squared plus the force of y squared. Okay. So I'm plugging and chugging. My force of my x is a square root of 1.05 newtons squared, right? Add negative 2.5 newtons squared. So if I put that in my calculator, so I'm going to go and say, all right, alpha x plus, which is my square root, open bracket 1.05, close bracket square, plus, open bracket, negative 2.25, close bracket, squared. What do you get? Well,
2.3625.
okay, I got 2.48294,804.
I forgot to add them.
Okay.
I got what you got, Miss Sloan.
Fantastic. Okay, so that gives me the answer for the net force, right? So up here, my net force, is it up, down, sideways, what? What direction is my net force in?
It's going down.
Down, correct. So my net force is going down at 2.48 newtons. Do you agree?
Yes.
Math, I do. What else do I need to do? I need to figure out the angle. Well, I'm going to use tan negative 1. Angle of tan negative 1 equals fx by fy. Okay? I'm looking for the angle. So based on that, I have my force net x is 1.05 newtons. I'm going to divide that by my y, which is negative 2.25 newtons. And what else am I going to do? Tan negative 1. There we go. Calculators. A second tan. And I'm going to do alpha y, enter to get my fraction. 1.05 down, negative 2.25, close my, whoop, move over and close my bracket. It's going to give me an error. Delete, delete, over, close my bracket. Now, what did y'all get?
Negative 25.01.
Yes, sir. So my angle is 25 degrees. So in here, 25 degrees is my angle. How's everybody doing?
I'm a little lost, but can you
Okay.
make sure you post this video today? Because you forgot to post the one from yesterday.
Shut up.
You did, but I'm more lost today, so I need this one more than yesterday's.
Okay, I will post it. So the first thing that I did is I took the apple, I drew the picture, I found the system. Once I found the system, the next thing I'm going to do is I'm going to find my variables for my y and my x. I'm going to draw them on here with all the forces that are applied. Then what I'm going to do is I'm trying to find my force net. I'm taking my x variable, my y variable, squaring it and square rooting it. That's going to give me my net force. And then I have to find my angle. But I will promise you, as soon as I get done today, and as soon as it gets processed, I will do it for you. And I'm sorry you're lost.
It's
Okay.
okay. I'll get found eventually.
All right, well, we got one more to do, praise God. So the third one says there's 2 tugboats pulling a barge across the harbor. One boat exerts a force of 7.5 newtons times 7.5 times 10 to the 4 newtons north, while the second is exerting a force of 9.5 times 10 to the 4th newtons, 115 degrees west. So we have a barge, right? In the harbor. We have 2 tugboats. And those 2 tugboats are exerting different types of forces. One's doing it north, okay? North, south, east, and west. One exerting it north. And one is exerting it north to west. Okay? This is tug 1, tug 2. And it's asking you precisely what direction does the barge move. So, our object is the barge. Okay? So, we have the barge. We have one that's applying a tension force for tug 1. And we have another one that's doing another tension force for tug 2. So right now, ours look like that. Do you agree?
Yes, ma'am.
Okay, so it says boat 1 has 7.5 times 10 to the 4th newtons that it's applying a force. Tug 2 is 9.5 times 10 to the 4th newtons there. And it's asking us what direction is the barge moving. So right now, that's what we've got. Okay? So, force 1 is going to be tug 1. Okay? It is 7.5 times 10 to the 4th newtons north. My force 2 is tug 2. 9.5 times 10 to the 4th at a 15-degree north of west. My angle 1 is 90 degrees. My angle 2 is at 180 minus 15, which would be 165 degrees. Now, how did I get the 90-degree angle? If I'm doing an angle all the way around to the other side is how much?
180, right?
180.
180. Does it make sense to you? Half of that would be right here.
Yes, ma'am.
That's where I got the 90 from.
Okay.
Okay? Now, if it says 180 minus 15, where did I get the 15 from? Because it told me it was at 9.5 times 10 to the 4th at 15 degrees north of west. That's where I got the 165 from. Remember, all the way around is 360. If the boat is halfway, that's 90. And then if this one is 15 degrees north of west, I would take the 180 and minus 15 to get my 165. Are we all on the same page so far?
Yes, ma'am.
Fantastic. So what it's asking for is it's asking us for the force net. Now, can I erase the top section? Okay. So if I'm looking for the force net, how do I find the force net of X? What did we use before?
We used the cos, right?
So we're doing the sign, that funny sign, right? Of XX, which would be, like you said, F1 cosine angle, right? Plus F2 cosine angle. That's the sum of force of X. Force Y net would be the sum of force Y, which would equal what?
That'd be force one's sine, right?
Yeah, of the angle, plus F2 sine of the angle. So let's start here with Fx net first. So we're going to take 7.5 times 10 to the 4 newtons cosine 90 plus 9.5 times 10 to the 4th newtons cosine 165. So I'm going to take my calculator. I'm going to do open bracket 7.5 times 10 caret 4 over close bracket. Cosine 90, close my bracket. I'm going to add 9.5 times 10 caret 4 over cosine 165, close bracket. What do you get?
Negative 91762.9535.
Perfect. Now let's go ahead and change our mode to scientific, please, because I would like to have a better number than that. Second answer equal, what do you get?
9.17 62953.
Yep. So I got 9.176295535 E4, and I changed it to 9.18 times 10 to the 4th power. That is my Fx. Now I have to do my Fy. I'm going to do the same thing as I did for Fx, except what am I going to do this time?
Sine.
I'm going to do sine. So 7.5 times 10 to the 4th newtons sine 90, just like I did up there, plus 9.5 times 10 to the 4th newton, same thing, sine 165. And I'm going to plug that into my calculator. Open bracket, 7.5 times 10 caret 4 over close bracket. Sine 90, close bracket, plus 9.5 times 10 caret 4 sine 165. Guess I'm wrong. Hello. Delete. I forgot to go over. Sorry. And then sine 165. Close my bracket. Sorry. I hit a button. 4 over close. Sine 90. Close bracket plus 9.5 times 10 caret 4 over sine 165. Thank God I did that right that time. So I got 9.96 times 10 to the 4th power. Did you get that?
Yes, ma'am.
Okay.
I'm getting like a really big number with no decimals, and I don't know why.
Abby, what mode your calculator in?
Degree.
Yeah, but is it in scientific or is it in the other one?
It's in scientific.
Take it out of norm and put it in scientific. And then once you do that, hit clear and then do second answer enter, and it should give you the smaller number.
I got 3.4.
Okay. I wish I had the app of the calculator on this thing so I could show you. But can you come in tomorrow a few minutes early and come sit in here with me, and it's just in the calculator problem. That's all it is.
Okay.
Is that okay?
I can come. Do you have a third block? Never mind.
I do have a third block.
I'll try to.
I was going to say, because I thought you came early enough, I could bother you just for a few minutes during homeroom and sit you in here and do it for a second.
Okay.
Call for me with toppings, right?
Yes, ma'am.
I'll ask her to see if it's okay first. And the only thing I'm going to tell her is I just need to see you for a few minutes, and then we'll sit down. I'm telling you, at the end of this class, you should be like doing this so quickly on this calculator once you get it hang of it. It's just getting it in the calculator correctly is the hard problem. Okay, baby?
Okay.
All right, so are we done?
No, we still have to find the angle.
God bless, we still got to do the angle. So for our angle, which I'll put up here, is tan negative 1 Fy net divided by Fx net. Okay? So we're going to take these numbers here, right? Okay. Calculator. So I'm going to go in here and I'm going to do second tan. I'm going to do alpha y enter to get my fraction. It says the y goes over the x. Well, this here is the x. This is the y. So I'm going to do 9.96 times 10 caret 4 over negative 9.18 times 10 to the 4th power over close. And what do you get?
4.73.
Yep. And it's E1, correct, Hunter? So let's change this mode to normal now. And let's see what answer we get this time. (47°), correct? Now, you don't have to change the mode if you don't want to. You can stay into scientific. And if your scientific answer is 4.73 E1, only thing you had to do is just move your decimal over 1 and you still get 47. But you don't want 4.7, do you, to the E1 or times 10 to the 1st power. You just want to go ahead and get a percentage. To do that, you could times it by 100 or you could just move the decimal over. Have I given you enough today? The only thing that's left on here is about equilibrium and the first law of motion and how an object stays at rest unless acted on by another object. Whenever you have an object that's at rest, you have a force normal and a force gravity. They're equal, and that's equilibrium. And that's it today.
God bless.
Well, I love y'all. And I will see you in the morning and tomorrow afternoon. I will post this, Bailey, as soon as it processes. It usually takes about 10 or 15 minutes, and I'll put it on there, watch it over again. Just remember, there is a process of how to do this, and make sure you understand cosine and sine. I'm going to give you a handout tomorrow, which I do have, that I give out to some people that kind of show you the grid line and how it's either sine or cosine, depending on which side of the grid it's on, and maybe that'll help also, especially with the X and Y axis.
Yes, ma'am.
Anything else I can do for y'all? Because Hayden's already left me.
That'll
Everybody-
be all. Thank you.
All right, guys, I love y'all, and I'll see you tomorrow.
See you
Yes, ma'am.
tomorrow.
All right, honey, bye.
Bye.